We're now going to discuss permutations with some identical items. Not all identical, but some of them. So let's say, for example, we have, so for all of these problems, we're going to have marbles. And they will be placed in order. From left to right. And the question is always going to be how many different orders. And what I'm going to change is I'm going to change the number of marbles, and I'm going to change the color of the marbles. And we're going to assume that marbles of the same color are identical. So if you have a red marble and you have another red marble, there's really no way to tell them apart. They're just two red marbles. Okay, so let's do this. So let's say we had a red marble, a green marble, and a cyan marble. The color of not getting much oxygen. So there's 3 marbles, and we're lining them up. And so there's 3 times 2 times 1. Another way of looking at it is there is 3 factorial, which is 6. Or if we really felt like it, we could list them all. I'm not saying we should, but we could list them all. So that would be red, green, cyan, red, cyan, green, cyan, red, green, cyan, green, red, green, cyan, red, green, red, cyan. There's 6 ways. So red, green, cyan is 6 ways. Now let's say, let's do B. Let's say we had 2 red marbles, so we still have 3 marbles, but 2 of them are red, and 1 of them is green. If we're going to list off all the orders, what we have is we have red, red, green, red, green, red, and green, red, red. And that's it. So those are the 3 orders that we can line them up in. Red, red, green, red, green, red, green, red, red. Now, the reality is that technically there's another one, right? Because there's still 6 ways of actually lining up the marbles. They just show up, right? So this one, let's say we have our first red marble and our second red marble, and this is our second red marble and our first red marble. But these are both the same thing. And again, this is red 1, red 2, red 1, red 2, red 2, red 1, red 2, red 1. So either way, there's 3, because what's happening is that each combination shows up, has another one that looks just like it. So we have our 6 combinations, but we could line them up in groups of 2. So our 6 combinations can be lined up in groups of 2. So we're really going to have 6 over 2, which is going to be 3. Or another way of writing that would be 3 factorial divided by 2, which is 6 over 2, which is 3. Okay. C. Red, red, red. Well, that's a little bit lame, but it's just going to be 1. We're going to come back to it another time, but there's really only one way to have 3 red marbles, and the answer to that is just 1. I'm going to point out, just to show that it's the same thing as 3 factorial divided by 3 factorial, which is 1. But we'll see why in a bit. Okay. D. Not red. Red. Green. Cyan. And purple. Red, green, cyan, and purple. So that's 4 marbles, and we're lining them up. 1, 2, 3, 4. 4 options for the first, 3 options for the second, 2 options, 1 option. It's just lining up 4 things. We've done this before. It's just 4 factorial, which is 24. Now, let's do E. Let's say we have 2 reds. Let's do a white. That might be easier to draw. A white and a cyan. So red, red, white, cyan. Now what we have is, so when we're lining these things up, so I have red, one way is red, red, white, cyan. But we could actually, kind of like the other one, for every one of those, there's actually 2 of them, right? Because there is red 1, red 2, white, cyan, or those red marbles could be the other way. And so each of those, but they both look the same. So for every way of writing, for every order of marbles, there's going to be one that looks just like it, but is going to have a different order of the things. Red, red, cyan, W. Red, W, cyan, red. Red, W, cyan, red. So it's going to be the same with the reds reversed. And so what that means is that of our 24 things, we could take our 24 things and we could write it in 2 columns. Each column is, remember, because there was 24 ways to line up 4 marbles, but now it's going to be 24 divided by 2. So so red, red, white, cyan is going to be 24 divided by 2. Which I'd like to point out is 4 factorial, and the number of ways that we could arrange the red ones within a given combination is 2. So divided by 2 factorial, which is 24 over 2, which is 12. I missed that off the screen there. 24 over 2, which is just 12.